Hi guys. So, over the last couple lessons, we've talked about factoring polynomial equations. We're going to shift gears today. We're still going to remember all those things we learned about factoring polynomial equations, but we're going to be talking about solving polynomial equations. And the easiest way to solve a polynomial equation is to set the equation equal to 0 and then factor it. So that works basically because of something called the zero product rule, which we talked about when we were solving quadratic equations. And it's still going to apply here. So the first thing we want to do when we're solving this problem, 2x to the third equals 12x squared minus 18x, is we want to set this thing equal to 0. Okay, so that involves me subtracting 12x squared from both sides, and also subtracting adding 18x to both sides. Now, remember, none of these things over here on the left-hand side are like terms, so we can't combine any of them together. So just keep that in mind. So, what do I end up with? I end up with 2x to the third minus 12x squared plus 18x. And on the other side, well, that cancels and that cancels, so I get equals 0. Okay, now, we can ignore the right-hand side, that whole equals 0 business, and we can, on the left-hand side here, just factor this thing. So let's see here, what can I factor, and how do I factor that? Well, first thing and always, I look for a GCF. All right, I got that. All right, don't forget the equals 0. We might be ignoring it, but we can't forget to write it. And let's see here, the 2x is a GCF. So then what's left? So then we just factor this here. We could just factor x squared minus 6x plus 9. Let's see here. When I factor that, I end up with the pair of numbers that multiplies to give me 9, adds together to give me negative 6, negative 3, and negative 3. So I get x minus 3 times x minus 3. Don't forget the equals 0. Okay, this is where things are different. Before, we would have been done with factoring polynomials, we would have been finished, but with this problem, we have an additional step, and that's simply to take each one of the factors and set them equal to 0. So I'll take each one of the factors and set them equal to 0. Yes, I'm going to set x minus 3 equal to 0 twice. Now the good news is if I do that problem once, I actually end up with the same answer 2 different times. Don't worry about this. That's okay. So, when I'm all said and done, I end up with the solutions of x equals 0 and x equals 3. Let's take a look at another problem. If you think you got it down, go ahead, pause the video, see if you can do it. Alright, so as I said before, the first step, set this thing equal to 0. So I'll subtract the 40x squared from both sides, minus 40x squared. There's no like terms on that side, so let's see here, what do I end up with? I end up with 5x to the third minus that 40x squared that I subtracted from both sides, plus 80 equals 0. Oh, 80x equals 0. So then I just factor. And what can I factor? Let's see here. I can pull out the GCF. The GCF would be 5x. So 5x. What am I left with after I factor out of 5x? Let's see here. I got x squared. I'd have, let's see here, minus 8x plus 80 divided by 5 is 16. So 16 equals 0. All right. Then we just factor out what I have left over in these parentheses here. So let's say I factor down x squared minus 8x plus 16. What do I end up with? X minus 4 and x minus 4. Don't forget about the equals 0. And then as I said, the additional step, set each factor equal to 0 and solve them separately. So let's see here. We end up with x equals 0. We end up with adding 4 to both sides. We end up with x equals 4. And x equals 4. So again, the solutions. X equals 0 and x equals 4. Alright guys, so right now, why don't you pause the video, try these 2 example problems, and when the video resumes, we'll go through this and I'll show you how to do these 2 problems. Go ahead, give it a try. Alright, so we're going to go ahead and start with problem number 2. There's a reason for this. We're going to start with problem number 2. Let's see here. I'm going to look. I'll factor out the GCF. So the GCF, let's see here. Just a 4. So I'm left with x to the 4th minus 10x squared plus 9 equals 0. So again, I'm looking for the pair of numbers that multiplies together to give me positive 9, adds together to give me negative 10. That pair of numbers, of course, is negative 9 and negative 1. So look what I did there, though. Remember, it's x squared because that's a quadratic-like equation. It's not a quadratic equation, but a quadratic-like equation. I'm going to keep factoring because I can keep factoring. So x squared minus 9 is the difference of two perfect squares. And then this here, this x squared plus 1, that's also the difference of two perfect squares. So I can keep factoring that down. All right, now just like I said each one of the factors equal to 0. Now check that out. Hold on, I'll come back to that. Okay, that's here. And I got x plus 3 equals 0. I got 2 more to do. I got x minus 1 equals 0. And x plus 1 equals 0. Okay, so let's talk about each one of these separately. So subtract 1. I got x equals negative 1. That's a solution. Add 1 to both sides there. I got x equals positive 1. That's a solution. Up here, subtract my 3. I'll get x equals negative 3. That's a solution. Add 3 to both sides. I'll get x equals positive 3. That's a solution. But 4 equals 0. That's not a true statement. This doesn't give me anything. So no additional solutions there. So my solutions, as I said, x equals 3, negative 3, 1, negative 1. All right, let's go back here and do number 1 now. So again, I'll look for a GCF. I'm probably going to pull the negative out as well. I think that's helpful. Pull out that negative 2. What am I left over with? Let's see here. X to the 4th. Whoops, minus 8x squared plus 16 equals 0. Okay, let's keep going. I got that negative 2 in that parentheses. That's a quadratic-like equation. Let's see here. That I can factor down. It would be x squared minus 4 times x squared minus 4. That's the pair of numbers that multiplies together to give me positive 16, but adds together to give me negative 8. And I can keep factoring. Let's see here. That's x minus 2 times x plus 2. And in that second parenthesis, same thing, x plus 2, x minus 2 equals 0. Okay, so now I said each one of the factors equal to 0. X minus 2 equals 0. X plus 2 equals 0. I'll go with the other ones. Hey, check it out. It's like the same thing twice. Whoops. Plus 2 equals 0. I end up with negative 2 as a solution, positive 2 as a solution. They show up again. And again, this negative 2 equals 0 doesn't give me anything additional. So, my solutions, well, it's just positive 2 and negative 2. All right. I want to look at this graph, negative 2x to the 4th plus 16x squared minus 32. We'll shift gears a little bit. I want to see what the graph of this equation looks like. And I've taken the time and I've actually graphed it out by hand. You can compare this in Desmos if you'd like to, but I'm going to show you here what the graph of that looks like. So now I want you to remember from the previous problem, when we set this thing equal to 0, we came up with the answers of 2 and negative 2. 2 and negative 2, when we set that equation equal to 0. These are the solutions to the equation when we set it equal to 0. They're also what we call the zeros of the function. Zeros of the function. And they just so also happen to be the two x-intercepts as well. X-intercepts at x equals 2 and x equals negative 2. Or 2 comma 0 and negative 2 comma 0. They all end up being exactly the same thing. So when we set an equation equal to 0 and solve it, we're not only finding the x-intercepts, we're also finding something called the zeros of the function. And that's going to come up. So important parts of this graph. First thing, as I said, the zeros are x equals 2 and x equals negative 2. What's a cool thing that happens is these occur twice. Remember how we had those twice? So they occurred twice. They occur twice. Both of them occurred twice. Remember in the previous problem how we had that negative 2 there twice and positive 2 there twice? So since they occur twice, they have what we call an even multiplicity. Multiplicity, it's just a word that means the zeros occur more than once. So it has an even multiplicity. When we have an even multiplicity, something really cool that happens is that the graph just kind of touches the x-axis and changes direction. Do you see how this graph just goes up? Oh, let me choose a different color. It just kind of goes up and touches the x-axis and then changes direction. Does the same thing over here at 2. That has an even multiplicity at 2 as well. That's kind of neat. If it has an odd multiplicity, it's just going to cross right through the graph. We'll see that later on in a different problem. So zeros are an important part. Multiplicity is kind of like a bonus thing for you to know. What else? What else do we see? We should also notice that the y-intercept is important. When we graph that, knowing the zeros, the x-intercepts, is important, but so is the y-intercepts. And in this particular problem, we have a y-intercept when I plug 0 into the equation, right? That's going to tell me where the y-intercept is. So negative 2 times 0 to the 4th plus 16 times 0 squared minus 32, that's going to end up negative 32. And that is the y-intercept right down there, y-intercept at 0, comma, negative 32. That's the y-intercept. Y-intercept. There we go. Right there. Okay. The last thing that's really important, something that's going to help us graph this, if you remember, is the end behavior. The end behavior. And remember what that means. That has everything to do with the degree and the leading coefficient. The leading coefficient. Okay, and in this problem, the degree is even, and the leading coefficient is negative. So if you remember what that means that both ends point down. Go back and remember that about that big chart that we had when we talked about end behavior and the degree and the leading coefficient. It was all the way back in section 4.1. You can take a look at that all the way back in section 4.1 in your textbook. Okay, let's move on. So what we're going to do is we're going to find the zeros of this graph, and then we're going to sketch it. We're going to end up and see what we have. Try to graph this thing without, knowing exactly what it looks like. And the first thing we want to find is we want to figure out what the x-intercepts are. Find the x-intercepts. The x-intercepts happen when we take our function, set our function equal to 0. 0 equals x to the third plus x squared minus 6x. Just like we did in the last problem, we're going to set that equal to 0, and we're going to factor it. Let's see here. What do we end up with? We end up with, at the end of this problem, x times x plus 3, x minus 2. Okay, and we set each one of the factors equal to 0. So let's see here. I get zeros at, minus 2 equals 0. I end up with a 0 at 2, at negative 3, and at 0. So this guy has 3 x-intercepts. 1 at 0, I'm going to plot that over here. Okay, 1 at negative 3, I'll plot that over here. 1 at 2, I'll plot that over here. Cool. All right, what else is helpful? The y-intercept is helpful. And that I get when I set x equal to 0. So what I really do, I'll evaluate that f of 0. That's kind of the notation we use. So we'll take and we'll plug that 0 into my equation. 0 to the third plus 0 squared minus 6 times 0. It's a lot of zeros. I end up with a y-intercept of 0 as well. So I actually already plotted that point there. I'll just plot it again for good measure. And the last thing I'm going to look at is the end behavior. The end behavior. So what happens? Well, let's see here. The degree is odd, and the leading coefficient is positive. So what does that mean? That means that my ends point in opposite directions, something like this. Okay, so going to the graph, what does that mean? That means I'm going to have one end of my equation going up, and the other end, this end over here, is pointing down somewhere. So I just have to make the graph look really good in between. Now, how can I do that best? Well, probably the best thing to do, in addition to looking at these things that we have, is to maybe create a table of values. Right? So if we create a table of values, that may help me some more. So, what points might be helpful? Maybe, well, since I know there's a 0 here at -3, right? Maybe a point before that would be helpful. So like -4, I plug that into my equation. -3, I know it's 0. I did that already. Probably go up from there. So like -2, -1. I know 0, 0 is a point. I already figured that out. 1, I'll figure out. 2, 0 is a point. Probably the last one I'll do is a coordinate pair at 3. So all I'm going to do is have my calculator out. I'm going to start plugging in some values into my calculator. So I'll plug in -4 and get -24 in my equation. I'll plug in -2 and I'll come up with 8 in my equation. I'll get the point -1, 6. I'll get the point 1, -4. And I'll get the coordinate pair of 3, 18. And then I can plot those points. I can go over here to my graph and I can plot those points. Let's here, -4, -24, that's way off the graph, so forget about that guy. But -2, 8, oh, he's going to be tricky, so that's 6. He's like up here someplace. We'll just put him up there anyways. -1, 6, that's that point right there. 0, 0, I got already. 1, -4 is that point. 2, 0, okay, I think I'm okay here. 3, 18 is way off the graph. So now I'll start connecting the points with what I know. So I know I got to start all the way down there. I got to go up here through the 0. I got to go all the way up to this point. Sometime I'm going to change direction and come back down again. I'm going to go all the way down through this point right here. Some point I got to go down here, and then I got to some point go back up again to pass through that 0 to end up with appropriate end behavior that's up here. And I just did a really good job of sketching my graph. I'm not looking for exactness here, folks, but just a nice sketch at what the picture looks like. Do your best, and then you can always check yourself in Desmos to make sure you did it correctly. All right, let's do another one. Okay, so we'll try one more here together. So first and foremost, we'll figure out what the x-intercepts are, and again, that's setting that function equal to 0. So we'll set 3x to the 4th minus 6x squared plus 3 equal to 0, and we'll solve it by factoring. There's a GCF of 3, so let's see here. So we'll factor out that 3, and then we're left with a quadratic-like equation in here. So that will give me x squared minus 1 times x squared minus 1 equals 0. I'll factor down some more. So 3 times x minus 1 times x plus 1, and it's the same thing again. That means we're going to have some multiplicity happening in this particular problem. So let's see, I'll set 3 equal to 0. I have x minus 1 equal to 0, x plus 1 equal to 0, x minus 1 equal to 0, x plus 1 equal to 0. So that's 1, -1. I'll end up with the same solutions again. So again, my solutions here for this particular problem. Wait, not solutions. Forget that. Let's call them x-intercepts. Are at x equals 1 and -1. Plot them. 1 and -1. That's it. Right? And they're multiplicity of 2. What does that mean? That means that the graph is just going to come down and it's going to kind of touch at that point and it's going to change direction. Or it could do it from this side. It depends. We'll have to figure out a little bit more information about that to see what's going on. So I erase that and we'll come back to that then. Okay, let's see here. So what else we got going on here? Up here. Well, let's not do green. Let's do blue. Up here. Let's figure out what the y-intercept is. And the y-intercept is going to be when we plug and make x equal to 0 into my equation. So that's here. G of 0 is equal to 3 times 0 to the 4th minus 3 times 0 squared plus 3. So that just equals 3. So I have a y-intercept at 3. Plot that over on my graph. Cool, cool. Then we have end behavior. And my end behavior, this is even and positive. So my two ends are going to point up. like this. So like up here on the two ends. Now, I actually went ahead and looked at the table of values for this ahead of time, so I know that I'm going to have a coordinate pair that's like the point 2 when I plug 2 into this equation. It's all the way up here at like 227. It's like off the page, and then negative 227 is up there too. It's like way off the page, so I'm not even going to worry about that. So what happens in this is my graph is going to be like pretty steep here. It's going to come down to negative 1. Since negative 1 has a multiplicity of 2, meaning it occurred twice, it's just going to bounce off the x-axis, change direction, come up, pass through the y-intercept, go back down, come back up again. Pretty cool. Nice looking graph. Go ahead and check yourself using Desmos, of course, to make sure that you know how to do that and what it looks like. But just some general characteristics that are pretty important when it comes to graphing polynomial equations. I hope you guys found this video helpful. As always, if you have any questions, please let me know. Good luck on your homework.